Good morning, dear students. I am Amrita, your chemistry lecturer. Welcome to today's session. Today we will discuss Beer-Lamberts law. I think in the previous class we learned Beer's law. Once you can recall the statement. Okay. So here Beer's law states that when a monochromatic light is passed through a solution, there will be decrease in the intensity of the light with the thickness of the solution is directly proportional to the intensity of the incident light and also to the concentration. So this is the statement of Beer's law. Okay. So let us discuss the limitations of Beer's law. So let us discuss the limitations one by one. So here in Beer's law, it is applicable only for monochromatic radiation. Okay, monochromatic radiation means the light consists of a single wavelength is known as monochromatic radiation. Okay, so here Beer's law is only applicable for monochromatic radiation. So this is the first limitation of Beer's law. And the second one is this law is only applicable for dilute solution. Okay, and the third one is the temperature remains constant. Suppose if you increase the temperature, it shifts the absorption band towards longer wavelength. So this effect is called as bathochromic effect. So this is all about the limitations of Beer's law. I hope the concept is clear to all. So next we will move on to today's topic, that is Beer-Lamberts law. So observe the diagram carefully. In this diagram you can notice the incident light. So the incident light is given as I0 and the transmitted light is given as I. So let us coming to a Beer-Lamberts law. Observe the diagram carefully. Here, according to Beer-Lamberts law, suppose if a beam of monochromatic light radiation of suitable frequency is passed through a solution. Okay, so it absorbs the solution. Due to the absorption, you will notice certain changes. So what are the changes you will absorb means, so first it will affect on the intensity of a light. How means the intensity of the light emerges from the solution is reduced. Okay, this is the first change. And the second one is the intensity of the light absorbed is given as IA is equal to I0 minus IT. Okay, here I0 is represent the intensity of a light absorbed and IT represent the intensity of the light transmitted. Okay, so let us observe the equation. So I absorbed, that is IA, is given by IA is equal to I0 minus IT. So this is the equation 1. So next you have to define the intensity of the beam. So here intensity of the beam is defined as energy falling on unit area perpendicular to the beam per unit time. So this is the definition of intensity of the beam. So here the photon of beam of intensity will be absorbed by the sample is proportional to the concentration and also it is proportional to the thickness of the absorbing solution. Okay. So next thing is, consider the equation 1, that is minus di by I is equal to alpha C into dx. So this is called as equation 2. So here on integrating equation 2, that means in order to integrate the equation 2, you have to take the limits value as case 1 I is equal to I0 at x is equal to 0 and case 2 I is equal to I at x is equal to b. By considering these two limits value, you can integrate the equation 2. Okay. So on integrating equation 2, you will get equation 3. So equation 3 is given as log I by I0 is equal to minus alpha C into B. So this is the equation 3. Okay. How do you get equation 3 means, integrate the equation 2. So equation 2 is given as minus di by I is equal to alpha c into dx. So integrate this equation 2, then you will get a equation 3, that is log I by I naught is equal to minus alpha c into b. So this is the equation 3. So here on multiplying 2.303 on left hand side of the equation 3, you will get a new equation that is called as 4. So equation 4 is written as 2.303 log I by I naught is equal to minus alpha b into c. So this is the equation 4. Then rearrange the equation 4. So on rearranging equation 4, you will get equation 5. So equation 5 is written as log I naught by I is equal to alpha by 2.303 into b into c. So this is the equation 5. Observe the equation 5. You can observe the certain changes. So the changes are minus sign is removed, and also log I by I naught is changed to log I naught by I. So this equation 5 is very important. So finally equation 5 becomes A is equal to epsilon b into c. Okay, A is equal to epsilon b into c. This is the equation 6. Here A is called as absorbance and epsilon is called as absorption coefficient. So the absorbance, that means the value of A is given as A is equal to log I naught by I. Okay. Then epsilon value is given as epsilon is equal to alpha by 2.303. By substituting these values, you will get a equation, that is equation 6, as A is equal to epsilon b into c. Okay. So next, so this equation 6 is refers the Beer-Lamberts law. So next consider the equation 4. So observe this equation carefully. Here equation 4 is given as 2.303 log I by I naught is equal to minus alpha b into c. Okay, this is the equation 4. So according to equation 4, the intensity of the beam of monochromatic radiation decreases exponentially with increase in the thickness. Okay, and the concentration of C of the absorbing medium. So this is the Beer-Lamberts law. So once again I will repeat the statement. According to equation 4, the intensity of a beam of monochromatic radiation decreases exponentially with the increase in the thickness and the concentration of the absorbing medium. So this is the statement of Beer-Lamberts law. Okay. I hope the concept is clear to all. So this is all about the statement and derivation of Beer-Lamberts law. Thanks for watching.